Today we're going to review our objective about solving and graphing inequalities. So remember your steps for solving. We look to see if there's any fractions to eliminate, any distribution that needs to be taken care of, combining any like terms on either side of the inequality sign. Then we identify the smallest variable and start undoing the order of operations to isolate that variable. So for example, here we've got 10 minus 12d is greater than negative 5d minus 4. So the first couple of steps involving undoing fractions and distribution do not apply, and neither does combining any like terms on the left or right side of the inequality. So we want to look at identifying the variables. We have negative 12d here, and we have negative 5d there. The lowest of those would be the negative 12d, so we should add that to each side. So that means 10 is greater than 7d minus 4. The variables are together, so we're going to undo the order of operations. So I see that subtraction of 4 to undo that, I'll add 4. So now 14 is greater than 7d. I have a multiplication going on. To undo that, I need to divide by 7 on each side. So I'll have 2 is greater than d. Now that's the rule that we have to do a graph of, right? So on our number line, we're going to want to show where that boundary is. So remember we talked about putting a 0, a 2, and since I went to the right, we're going to go 2 to the left. And 2 is our boundary. We want to see if that is going to be a solution. So is 2 greater than 2? No, it's not. So I'm not going to use that point. All right, is 2 greater than, let's say, 0? Yes, it is. Is 2 greater than negative 2? Yes, it is. If I pick a number over here like 5, is 2 greater than 5? No, it's not. So I know I'm going to have to be shading everything to the left of my boundary to show my solution. So my graph should look like this for my rule. All right, let's try another one. Here we've got 6 times the quantity x plus 8 is greater than 6x plus 52. Thinking of our rules, right, we have some distribution we have to take care of. No simplifying on either side of the inequality sign, so lowest variable is 6x, so I should subtract that from each side. And then I've got 48 is greater than 52. I know that's not true, so I know that it's a no solution. So I wouldn't have a number line graph for this one because there is no values that could make that true. Let's try one more. Here we've got x minus 4 plus 2 times the quantity 4x plus 5 is less than or equal to x minus 18. Let's have you pause the video and try to do your steps to solve and graph your inequality, and then you can resume when you're ready. We've got some distribution to do here, and by the looks of it, we'll then have some like terms to combine on the left-hand side. So that's for my distribution. I've got some variables to get together and some constants to get together. So that would breed this. Everything is simplified on each side of the inequality. So again, we're going to say, hey, what's our lowest variable? That would be the x here. So I've got to undo that by subtracting each side by x. So that would bring me to 8x plus 6 is less than or equal to negative 18. I see the addition of 6, so to undo that, I'll subtract 6 from each side, which means 8x is less than or equal to negative 24. I've got some multiplication here to undo, so I'll divide each side by 8. And that means x is less than or equal to negative 3. So what would our number line look like? Well, we'd have to have our number line with 0 in the center. I want to see a -3, and if I'm going to left 3, I need to go to right 3. When I think about what's happening at -3, would that be a solution? Well, if I put -3 in for x, -3 is less than or equal to -3. That's true. Where are all the other values that would be less than or equal to -3? That would be to the left on our number line. So I should have a filled in boundary point because that was a true statement, and all the other values that make it true to the left is shaded in. We've been doing a lot of work with solving equations and inequalities. And the biggest thing when we're not given an equation or inequality right away to solve, but if we have to write one, is trying to pick out those important clue words, right? So equations, we're trying to think of equivalencies, right? What words could we use to represent that versus inequalities? When we're talking about equivalencies, keywords we're going to look for in our word problems are same, equal, equivalence, giving me a sum, or giving me a total. Conversely, if we're talking about inequalities, I want to look for words like the obvious, greater than, less than, at least, at most, minimums, and maximums. So let's see if we can take a scenario to write some equations and inequalities and go from there. So here, a fitness center offers beginner yoga classes for $10 per class and sells yoga mats for $19.95. You paid a total of $139.95. How many yoga classes did you purchase? Well, if we think about our problem-solving techniques, right? Underline what you know, circle what you want to know. We know that it's $10 per class, and you have to get a yoga mat for $19.95. We know we've paid a total of $135.95. Question is, how many yoga mats did we purchase, right? So right here, sorry, how many, not yoga mats, yoga classes did we purchase? Since I don't know the number of classes, that would be my variable. It's saying I'm paying a total, so we know that this has got to be an equation, an equivalency word. So let's let C equal the number of yoga classes. I know that I'm $10 per class, so I could have 10C plus the $19.95 to equal $139.95. Now, all I have to do is to undo the equation to solve for C. So I see this addition of $19.95. I'll subtract that from each side. Then I can divide by 10 and see that it will take 12 classes to have that total. So I'm going to write my sentence is that you attended 12 yoga classes. And let's look at this scenario. A fitness center offers beginning yoga classes for $10 per class and sells yoga mats for $19.95. You want to spend at most $100 on classes. What's the maximum number of yoga classes you can purchase? This is similar, but it does have a couple of differences that should really stand out. We're still doing the $10 per class. We're still paying $19.95 for a yoga mat, but now it says you want to spend at most $100 on your classes. And the question is, what is the maximum number of yoga classes you can purchase? So notice how they're saying at most, maximum. Those are our key words to write an inequality. So we're going to set it up the same way as C being our variable for the yoga classes. So 10C plus $19.95, but it says at most, so I cannot exceed that. So that means I need an equality symbol. The inequality symbol for at most would be less than or equal to. So now we have our inequality, and we're going to undo it with the same procedures that we had before, right? We're going to subtract our $19.95, divide by 10, and that gives us C is less than or equal to 8.005. Now remember, C is the number of classes. Can you take 8.005 classes? That's not possible. You either take the class or you don't. So we're going to have to say, at most, you can attend 8 yoga classes. Let's try another scenario. Brian and his band want to record and sell CDs. The recording studio charges an initial recording fee of $250, and each CD will cost $5.50 to burn. Those are some pretty important things right now, so I'm going to underline the recording fee and the cost for each CD to burn. As I'm keeping reading, the studio requires bands to make a minimum purchase, sorry about that, a minimum purchase of $850, which includes recording and burning of the CDs. What is the minimum number of CDs your band must burn? Well, again, minimum number of CDs. That's our clue as to what our variable needs to be. So the question is it going to be an equation or an inequality? The big clue is here when it says a minimum purchase. Minimum means you can spend that amount or more. So this is going to be an inequality. So if I let C be the number of CDs being burned, right, and I integrate what we know, the $250 initial fee, $5.50 for every CD, and we're going to spend a minimum, right, that amount or more for the studio. Now we just have to undo this to try to get C alone. So I see this addition of 250. I'm going to undo that with subtraction. I see my multiplication here, so I got to undo that with division. And I see that C is greater than or equal to 109.09 repeating. Again, C is representing the number of CDs. I can't make 0.09 of a CD. So what would I say? We have to round this up because 109 CDs is not going to be enough to make that minimum requirement from the studio. So we're going to have to say the band must burn at least 110 CDs. Continuing on with the studio example, what if they offer you another option? If the initial setup fee of $250 is reduced by 50%, but the cost per CD and the minimum purchase requirements do not change, how many CDs will you burn now? Let's have you pause the video and see if you can write your rule based on that requirement, and resume when you're ready. The recording minimum did not change. The price for the CDs did not change. The recording initial fee of $250 is reduced by 50%. That means it's $125 now. This would be the model for this option the studio is giving you. So if we want to start undoing this to solve for C, we're going to follow the same procedures as before. So the variables are all together. I'm going to undo this addition of 125. Then I see this multiplication, which means we have to do some division. And then see what our rule ends up being. It says C is greater than or equal to 131.81 repeating. Again, we're running into that problem where we can't make 0.81 of a CD. So we're going to have to round up. So in this option, you would have to burn at least 132 CDs to meet this studio's requirement. Now it's your time to do some more practicing with solving equations and inequalities and writing equations and inequalities to solve. Please consult the post on Google Classroom for what to do with the practice problems for Unit 1, Day 5.